Today, lesson 22B, the second day of two-dimensional geometry. Yesterday, our focus was on circles. And so what that means, basically, is this. If we put together the two-dimensional shapes that you talked about from 6th grade and so far this year, and I know some of you did talk about circles last year, but now that means you know how to find the area or perimeter of circles, trapezoids, triangles, rectangles, parallelograms, squares, and so on. But sometimes we have partial shapes, or shapes made up of other shapes. And that's what the idea of irregular or composite shapes comes from. And so part of what we're going to be doing today is breaking shapes into shapes that we know and calculating the area from there. So we're going to start off today by looking at parts of a circle. And we're going to start with parts of a circle because circles, that was our focus yesterday. And I'm bringing back in the actual standards to show you why we're doing what we're doing. And this is what we did yesterday. And then today we're bringing in another geometry standard, and we're bringing in the area part. We will eventually get to the volume and surface area part. But we're dealing with it shapes that are composed of triangles, quadrilaterals, or other types of polygons. All right, so irregular or composite shapes. So we have three shapes up here. With your shoulder partner, I would like you to talk about how you might find the area of each of those shapes. Now, we know how to find the area of a full circle, but how might you go about trying to find the area of each of those shapes? I'll give you about a minute. Go ahead. So in some respects, this is sort of the idea of what's happening today. I heard lots of discussions about different things, but when I look at the semicircle up there, I look at that in terms of you could find the area of a full circle, pretending like it was a full circle, and take away half a circle, because then what's left is half a circle. Or you could have just taken the area of half of the full circle, because that's really what that is. The one to the right of that, I heard discussions, well, that looks like that's 3/4 of a circle. And it is. So one thing you could do is find the area of the full circle and take away the quarter circle that is really cut out of that thing. Or, since it's 3/4 of a circle, you could find 3/4 of the area of the full circle. And there's always going to be more than one way of doing these things. And it should be clear to you that that last one there is 1/4 of a circle, and that's probably the fastest way of doing that. So pretend like it's a full circle, find the area, and then take 1/4 of that. All right, so speaking of 1/4, number one, it says the corner shelf is in the shape of the picture below. It has a radius of 5.5 inches and is 1/4 of a circle. Find the area and round your answer to the nearest 100. I would like you to try that with your shoulder partner. All right, so if we pretend like we're finding the area of a full circle and then take 1/4 of that, that's the way that I would go about trying to do it. So pretending that it's a full circle, the radius is 5.5, and to find the area of a circle, it is pi times the radius squared, so the radius is 5.5, and I always leave it in terms of pi and then multiply by 3.14. So in other words, I would find the 5.5 squared part first, which is 30.25. Now I will multiply that by 3.14, and that is 94.985. But that's the area of the full circle. From there, we have to take 1/4 of that because we have 1/4 of a circle. So one way of finding the 1/4 of that, I saw a few of you multiply by 0.25, which is fine. I'm just going to divide by 4 because that's the same thing. Multiplying by 0.25 and dividing by 4, same thing. Now at that point, you're going to get something like 23. If you finished off the division, it would be this right here, 23.74625. But it does say to round to the nearest 100th, and so that would mean to the nearest 100th would be 23.75. We do have units here, so inches squared. 23.75 inches squared. Any questions with that problem? We have to pay attention to our multiplying. So how would we go about that? Let me go ahead and take this off here and finish this. So how are we going to find the distance around that shape? How are we going to do that? Okay, so what's the diameter? Okay, the diameter is 11. Then what are we going to do? Multiply by pi. Okay, so let me get started on that. So we do need the diameter, and the diameter would be 11. And so if we multiply that by pi, we end up with this, 34.54 inches. Is that the circumference or the distance around that entire shape? No? What are we going to have to do now? Yeah. Divide by 4. Okay, so everybody go ahead and do that. So once again, what I tend to do is I tend to pretend like we have a full shape and then deal with it at the end. Deal with the fact that this is 1/4 of something. Anybody have that yet? 34.54 divided by 4? Is that what it is? 34.54 divided by 4 is 8.365, yes. So you divided that by 4, and you have 8. What? What did I say? Oh, okay. Well, that's what I was going to write. All right. So is that the distance all the way around that thing? Yes or no? Uh-oh.
Wait, no.
Okay, what that is that's the distance from here to there. Around 1/4 of a circle, right? We're supposed to find the distance all the way around. So I have to add on 5.5 and 5.5. And that's the reason why I wanted to do this specific problem, because we do have to think about the fact that when we are finding the distance around, we have to really find the distance all the way around that shape there. And so that would be around 19.635, and I'm going to make sure I say it correctly that time. Okay? All right, everybody try number 3 with your shoulder partner, please. Try number 3. All right, the circumference of the circle below is approximately 125.6 centimeters. The shaded region is 3/10 of the whole circle. What is the area of the shaded region? So we need to sort of think about it in these terms. We need to find the area of the full circle and then find 3/10 of that. And finding 30% of something or 3/10 of something or 0.3 of something, those are things we've been working on all year long with various types of problems. So we're going to need to find the area of that whole thing. And in order to find the area, we need to know what the radius is. So if we take the 125.6 and divide it by pi, or 3.14, that'll tell us what the diameter is. And so the diameter is 40, which means that the radius happens to be 20. And some of you went about it in a various number of ways, but I heard a lot of you say you did know that the radius was 20. That's the first thing you had to do, because we need the radius to find the area. So if the radius is 20, that means that the area will be 1,256 square centimeters. But that's the area of the entire circle. We're concerned with 3/10 of that. And so we could multiply 3/10 times 1,256. We could multiply 1,256 by 0.3. Either one of those will give you the same sort of deal. But we should end up with 376.8 square centimeters. 376.8 square centimeters. All right, so we talked about parts of circles. Now let's talk about different shapes or parts of different shapes that are connected together. Now these shapes are not in your notes. I just want you to look up here. So what different shapes make up the composite shape? So let's talk about the blue shape that looks like an L. What shapes make up that shape? What shapes? Yeah. Rectangles? Okay. So like that tall rectangle and that square actually right there. Depending on how you look at it, it might be two rectangles or it might be a rectangle and a square. The bottom one, and I didn't mean to press that, but we can see that it's composed of a semicircle, and the bottom part of that is a rectangle. And so if we wanted to find the area of each of those shapes, we would find the area of shapes that we know and then find the sum of them because they're composed of those shapes. Here's a couple more. That blue arrow is composed of a triangle and a rectangle. So if we found the area of the triangle and the area of the rectangle and added them together, that would give us the entire shape. The green thing is a trapezoid sitting on top of what looks to be a square. So if we found the area of each of those and added them together, that would give us the area of that composite shape. So that leads us to our next problem. Samantha is looking down at the hotel pool from her 10th story window. She is wondering what the area of the pool's floor is. Help her find the area of the pool's floor. Well, you have these basic dimensions right here. One suggestion that I usually tell people is to fill in all of the other sides too, because there's always more than one way of breaking this up. And so what I mean by that is this. This side right here is missing, and this side right here is missing. Let's go ahead and fill them in, because we might need them. We might not need them, but we might need them. Anybody know what the length of that side is? And we're talking about from here to here. Go ahead and tell me. It is 8, because if it's 8 from there to there, and 16 all the way across from there, it has to be 8 right there. So that means that this side right here, of course, is 8 meters. How about this side right here? Just tell me. It's 3, because if it's 9 from there to there and 12 all the way across, we can tell it's 12 because of that right there. That means it has to be 3 right there. So let me get rid of my mess here and fill those in. And so we now need to figure out how we want to break this up. Well, the way that I look at it is there's several different ways. One way you could do this is you could break it up right there, so that we have this rectangle right here and this rectangle right here. So if we do that, the picture ends up looking something like this. We have this one, which is 12 by 8. By the way, what's the area of that rectangle? Tell me, please. It's 96. And then we have that rectangle right there. Tell me what the area of that one is. So one of them is 96. The other one is 24. Those are the two shapes that make up that shape. So if we add those two areas together, we have the composite shape. So that pool has an area of 120 square meters. Now, you didn't have to break it apart that way. And that's why you have 2 of these shapes in your notes, because you could have also thought of it this way and break it off right there. Now, if you did that, you have this rectangle that is 8 by 9. I know it looks like a square, but it's not quite a square. And then we have that top rectangle that is 16 by 3. And so we have one shape that has an area of 72, and the other one has an area of 48. We can still see no matter how we break that up, we're still going to get the same area, and we should, of 120 square meters. So for the next 2 shapes, that's basically what we're doing. We're trying to break it up into shapes that we know, because these irregular shapes are composed of shapes that we do know. Okay? All right, so everybody try number 5. And just like in the previous one, if it is possible, label all the sides. If it's not, you just do what you can do. All right, so when I walked around, some of you broke it off like this into that right triangle that you have on top and then the rectangle down below. The rectangle down below has an area of 48. For the right triangle, we're going to have to do some figuring out of some sides here. So if it's 8 from here to here and 12 all the way across, that means this is 4. And if it's 10 for that whole height right there, and 4 from there to there. That means this has to be 6. And to find the area of a triangle, it's 1/2 the base times the height. 6 times 4 is 24. Half of that is 12. So 12 and 48 makes 60 square feet. That's one way of doing that. Another way, I saw some of you do this. You broke off the trapezoid there, and that's fine as well. If you did the trapezoid, you'd have this rectangle right here, which has an area of 32. And then for the trapezoid, we're going to need several pieces here. We need this, which is obviously 4 because this is 4. That's one of the bases. And then we need the height of that thing. And the height of that thing, if it's 8 or 12 all the way across and 8 from there to there, that makes this 4. So the sum of the bases is 14. We'll multiply that by the height and then take half of that. So that's 56, so that's 28. 28 and 32 is, once again, 60 square feet. Does not matter which way you break it up. Okay? All right, try with your shoulder partner. Number 6. Now, when I walked around, I saw 2 different ways. I saw some of you who saw that if you break it off right there, you have a trapezoid sitting on top of a rectangle. To me, that's probably the easiest way of doing it because you have this rectangle right here. And then for the trapezoid, we need this, which is obviously 36 since it's 36 there. We have the 20 there. We do need the height of that trapezoid. But if it's 14 from there to there, it's 14 from there to there. 20 all the way across, that would mean it would have to have a height of 6 there. So that would give you all the information that you would need. Some of you did this. You saw it as a trapezoid that's sideways right here, and then another trapezoid right here, and then with this rectangle in the middle. So you have 2 trapezoids and then a rectangle. I mean, it does not matter how you go about trying to find the area of that, but your area should be 672 square feet. Now you had to get that part right in order to... Is there anybody who needs me to work that out? Yes? Which way did you try it? With just chop right here? Yeah. Okay, what's 36 times 14? 564? It's what? So this one is 5. This one's 504. Is that where you made your mistake? Okay, so we have 36 here, and adding the 20, so that's 56 times the height, which is 6. And then we're going to take half of that. So 3 times that would be 168. No, not 168. What would that be? 159. 159. It's 36 all the way across there, and 20... 168?
Yeah.
Okay, all right, okay. And so that would give us what we need right there. Okay? Yes? Okay. So we had to get that part right in order to do number 7. And number 7 asked, well, if the cost of wood for the deck below is $5 per square foot, find the cost of building the deck. Well, you'd have to take the 672 and multiply it by that 5, so it would be $3,360. Okay? All right, so let's go to the last idea for today. So far, all the shapes have been composed of other shapes. But sometimes what we have is we have a situation where we have a shape and something is cut out of it. So before we even go into that, yesterday I tried to make certain that you understood that leaving things in terms of pi as long as possible is very important. And for this type of problem we're about to do, that is the case. We all know what 5x plus 6x is. That's 11x. Well, what do you think 5 pi plus 6 pi is?
11 pi.
It's 11 pi. The same way that if you have 5 negative 1s and 6 negative 1s, that's 11 negative 1s or negative 11. And so what do you think 12 pi minus 3 pi is?
9 pi.
Yeah, so we're going to be dealing with things where we have to leave things in terms of pi until the very end. So if we take a look at this right here, This is a picture of a big circle with a smaller circle cut out of it. Do all of you see that? So the big circle, or the outer circle, if we take away from that the inner circle that's cut out, what's left is actually the shaded region. Because it was a large circle that has, by the way, a radius of 4, because it's 2 from here to here, and then another 2 from there to there. And then we're going to take away from that the inner part. So we're going to cut that out right there. And that inner one happens to have an area of, or not an area, a radius of 2. So the outer circle had a radius of 4, so that means in terms of pi, the area is 16 pi. And we're cutting out of that an area of 4 pi. Notice I have not multiplied by 3.14 yet, because I want to leave it in terms of pi as long as I can. What's 16 pi minus 4 pi? It's 12 pi. Now I will multiply by 3.14. So I held off as long as I could to multiply by a decimal. And if I had not mentioned that, many of you would have multiplied probably by 3.14 right here. Then you would have had to have done it again. And then you're going to have 2 decimals you have to deal with. So you would have had to have dealt with decimals 3 times instead of just 1 time. So are there any questions on this idea right here? One shape cut out of another shape. All right, so that leads us to our last problem for today, and it is this. Larry just put in a circular shaped flower bed as shown below and surrounded it with concrete. He wants to know how much paint he needs to paint the top of the concrete. So he's going to paint this concrete right here. He's going to paint the top of it all the way around. He wants to know how much paint he needs to paint the top of the concrete, and the concrete is 1 foot wide all the way around. So the radius from the center of that circle all the way out to the edge over here is 8.5, and you know that the concrete is 1 foot wide. I want you to find the area of that in terms of pi, and then I'll give you the decimal answer from that. Give me what the area of that concrete is in terms of pi. Work on that with your shoulder partner, please. So basically what we have here, and it's a little harder to see from the picture that's there, but you basically have an outside circle, and you're cutting out of that an inside circle. The outside circle has a radius of 8.5, and that concrete right there only has, it's 1 inch, or not 1 inch, 1 foot wide. So basically what you have is you have the outer circle area, which is 8.5 squared pi, pi times the radius squared, and we're going to take away from that the radius of the inner circle. If the concrete is 1 foot wide, that means the inner circle has a radius of 7.5. That should make sense to you. And so I asked you to leave it in terms of pi. So 8.5 squared is 72.25. 7.5 squared is 56.25. So in terms of pi, that would be 16 pi. And then I told you I would give you the decimal value of that. So that would be 50.24 square foot or square feet of paint.